Hi guys, and welcome to today's video on counting permutations. So in this video guys, we're going to learn to count the number of possible options when the order of those choices in making those options choices matters. When you count options, sometimes the order is important. That's why we're learning this. And you'll know you're successful when you can count the number of ways to arrange objects like books on a shelf. So, permutations. The definition of a permutation is an arrangement of all or part of a set of objects with regard to the order of the arrangement. So you're picking objects, you're not putting them back, and then the order of those, order in which you did so matters. For example, you have a set of 3 letters, A, B, and C. If you want to know how many ways you can arrange 2 letters from the set, you would line them up, and then we would find that each possible arrangement would be an example of a permutation. So A, B, A, C, BA, BC, CA, and CB are all considered unique within this set because C in the first spot is different from C in the second spot in all of the cases. Same with B and same with A. So that's what a permutation is. Now, in addition, with this type of counting, in that the order of our selections is important, we are assuming that we cannot ever repeat a choice, meaning that once we have selected a person or thing, they're done and they cannot be selected, and the thing that we picked cannot be picked a second time. So we can calculate the number of permutations by using the following formula. P of n comma r, where n is the number of available options, so the whole amount of stuff in your data set, and r is the number of the selections we must make, is equal to n factorial divided by n subtract r factorial. On your calculator, you can go to the math menu, press the right arrow button 3 times to be under the PRB probability menu, and then use option 2. I use this calculator shortcut in all of my calculations. Alternatively, you can use the factorial button found in the same menu to do the same calculations. So, factorials, okay, an exclamation mark means factorial. It's an operating symbol telling us to multiply that number by all of the whole numbers that are less than the original until you get to 1. So 1 factorial is 1, because there's no other numbers. 2 factorial would be 2 times the 1. And then there are no more numbers. 3 factorial would be 3 times 2 times 1, because there are no more numbers after 1. 4 factorial would be 4 times 3 times 2 times 1, or 24. And 5 factorial would be 5 times 4 times 3 times 2 times 1, for 120. So if you wanted to go even further, you could do 6 factorial, which would be 6 times 5 times 4 times 1, 2 times 1, and so on and so forth. But you get the idea. All right, so let's do some examples. There are 7 flute players. They're going to perform in an ensemble, and they'll have their names listed in a program. While waiting to go on, the players wait backstage. There is a single bench that can seat 4 of them. How many possible seating arrangements are there? Well, seating arrangements, if you just draw out a bench and put 1, 2, 3, 4, so 4 spots for someone to sit down on. Okay, someone sitting in the 1 position is different from them sitting in the 3 position. So that's our big tell here, that order matters. And that we need to use the NPR. So I have 7 flute players, so N equals 7. And 4 of them are going to be chosen to sit down on the bench. So I can then put the formula in 7 NPR 4, which becomes 7 factorial over 7 minus 4 factorial. And when I go ahead and calculate that, it leaves me with 840 arrangements. So there are 840 arrangements or ways to seat the flute players. So there's 840 different arrangements, or 840 ways to arrange the flute players. Okay, how many unique ways can I arrange the letters A, B, C, D, E, F? So 1, 2, 3, 4, 5, 6. So I have n equals 6 here. And the word arrange is kind of my tell that order matters. So I need to use NPR. So R in this case is also going to be 6 because it says how many ways can I arrange the letters. It doesn't say like a small amount of the letters. It just says can I arrange the letters. So essentially what we're doing is picking all of them. So that means R is 6. R can be equal to or less than the N, but N must be greater than R or equal to. So it would be 6 NPR 6, which turns into 6 factorial over on the bottom, 6 minus 6 factorial. This would be 0 factorial, but if you calculate 0 factorial, you get 1. So then I get whatever 6 factorial is, and 6 factorial is 720. So there's 720 ways to arrange A, B, C, D, E, F. In a similar fashion, how many ways can I arrange 3 of the letters? So it's still n equals 6, but instead of picking all 6, this time we're only picking 3 of them. So it becomes 6 NPR 3, and that would be 6 factorial over 6 minus 3 factorial. So it would be 720 on the top divided by 3 factorial on the bottom, which is 6. So 720 divided by 6 is 120 ways. And if you put in 6 NPR 6, you get 720. If you put in 6 NPR 3, you'll get 120 ways on your calculator shortcut. All right. Next one. There are 12 companies competing in the Olympics for team gymnastics. 12 countries, not companies. Countries. How many different ways would it be possible to give out the gold, silver, and bronze for this event? So gold, silver, bronze represent awards. They represent ranked awards. And ranked awards imply that order matters. So what I can do then is make sure that means I need to use NPR. I have a pool of 12 countries to choose from. I must select 3 of them for the awards. So then it's going to be 12 NPR 3, which would turn into 12 factorial over 12 minus 3 factorial. And that leaves me with 1,320 ways. So there are 1,320 ways that I could give out the gold, silver, bronze for these 12 countries. Okay, a company's employee ID code is generated using 2 numbers, 1 to 5, which cannot be repeated, followed by 3 letters from A, B, C, D, which also cannot be repeated. How many unique codes can be made? So we're talking about multiple outcomes here. So multiple outcomes, remember that means we need to multiply. So first, let's find the outcomes for the numbers. So for the numbers, I have 5 options, and I've got to pick 2 of them. So it would be 5 NPR 2, which would be 5 factorial on the top over 5 minus 2 factorial on the bottom. And then if I set up the letters along the same way, I have 3 letters are being chosen. 3 letters are being chosen. And there are 4 letters in that pool, A, B, C, D. So it would be 4 NPR 3, which would turn into 4 factorial over 4 minus 3 factorial. On the top for 5 NPR2, so 5 options, 2 choices, there are 20 ways for that to be chosen. And for the bottom one, 4 ways or 4 options, but 3 have to be chosen. There are 24 ways for that to happen. So I'm going to multiply those, since multiple outcomes means multiply, and that gives me a total of 480 unique codes. So I could generate 480 unique codes before running out with those parameters. So I hope the company is a small company, but if it was, it could definitely work out. And that's it, guys. Permutations are specific ways of counting the number of ways we can accomplish or select options from a larger set of variety of possibilities where the order of those selections matters. And we can calculate with the formula, and then there's also the calculator shortcut to do so. The calculator shortcut N, the number of available options, you're going to have a P in there, and then R, the available number of choices we are making. For example, 15P10 would mean you have 15 options, and then you're going to pick 10 of them. That's it for today's video, guys. Thanks for watching, and I'll see you in the next one.